Okay, can you hear me? Yeah, we're good. Okay. Today I want to talk about scaling React apps. My name is Scott, as you have already heard. I work at FanDuel as a senior engineer. I mostly work in the web team on our kind of like web platform, and I spend most of my days writing like JavaScript. A bunch of other things, but most of my time is JavaScript. I didn't touch anything. Okay, that QuickTime thing is gonna kill that. Okay, that's a video. Sorry about this. Cool. We're back. Right. So yeah, at FanDuel, we really like React. We have like a bunch of React engineers. We are super into it, and I'm not here to sell React. Obviously, it's a React meetup. So, in our React codebase at FanDuel, we've got around about 200,000 lines of JavaScript, kind of all the way across our like fantasy product that has been building for, in this codebase, like 3 or 4 years, and then another 10,000 lines of TypeScript. We're kind of like building on that. Overall, like 250,000, something like that, with all the copy and stuff like that. And then we have about roughly 20 growing fast web engineers, specifically probably 100 plus, 150 maybe engineers across the company, split between here, New York, and Glasgow. Cool. So React apps. Everybody that starts in a React app with state management. This is a phrase everybody uses, and pretty much everybody, without a doubt, reaches for Redux. This is the thing that you use. If you write React, you all have definitely heard of this library. We're big fans. We're big fans from the start. It's fairly well baked into the app. We are not really going to get away from this. But this is mostly around how you handle Redux, right? Like at the point where you have a large amount of reducers, you have a big store, you don't really know where you're going to put stuff. You want to make sure you're not duplicating it. This is a big problem. So yeah, generally, the good thing about Redux is that when we onboard new people and they've not used it before, it's fairly simple to understand. You've got your reducers and you've got your actions, and we find it it's not too difficult. It's not this kind of whole other API that you've got to learn. So scaling this has been tricky. Yeah, this is mostly what we use it for in the end of the day. Like where we put things, we put API requests. We take the request and we stick it in the store. We break it down by the type and the ID. We store some stuff about like the global state, like the user settings and the locale and things like that. And then we also put some view state in, like what the current state of that specific screen is. Probably the only thing that should be in the store is the global state. It's super easy because of all the abstractions we've got now to just keep putting things in the store. It's really easy to put them in and get them back out again, and people just start defaulting to it, to the point now where specifically for API responses, we have so many documents that come from the API, so many reducers to handle them all, that every time you fire one action, we specifically filter all of the actions that go near any of those API reducers, because there is 150 plus. And so if you put something like a button click, or like a toggle where someone's setting something, you're like one button click is just triggering a whole bunch of stuff, and you get this like short burst of lag in the UI. So we filter those specific action types out and don't send them to reducers unless they are like an API request coming in. Yeah, that's exactly what I just mentioned. Oh, not this again. Let me try a different port on my machine. So work hard on data normalization and hydration. So yeah, with multiple API documents, and you say, I want a user and I want their balance, but we have a balance in a different document in the API. So we have the user's document and the API, the balance document in the store, creating like tools and libraries and stuff like that inside of the codebase to make that easy and simple is hard. Like the ones we have are not great. We get by with them, and it's difficult to onboard people. I would say work hard on fixing this problem and fixing it well. The really, really easy solution to it is GraphQL. We have some. We are getting there. It's a fair amount of learning on top of it, but it solves this problem really well. And yeah, really just work hard, make sure you need it. If you're going to cache stuff in the API or put it in the store, think hard if you need a cache. Don't unnecessarily cache that stuff. Just kind of take the easy option. Don't solve problems until you actually have them. These two, if you've been playing around with hooks at all, these two are amazing. These kind of solve a lot of our problems. We can just pull a specific piece of the store out, pull the reducers out of it, stick them in a use reducer, and then pull them in with use context. And yeah, it makes this kind of decoupling problem that we have with Redux. Takes this like single dependency and splits it all up, and we only kind of subscribe to things that need to be subscribed to. But you lose this. This is super great. In a big React app, when we load some pages and dispatch 150, 200 actions on page load, you want to know when a bug happens or a console error gets thrown, where that happened, what state the page was in when that happened, and not having DevTools is going to be painful when you're just using hooks. So this is another problem people come across with Redux. You build a front end, you talk to an API, right? You've already got this problem. We use a library called Redux Thunk. This is the simplest one. Loosely, this is what this library lets you do. Instead of dispatching an action type, an action, which is a plain object, you dispatch a function, and that function, Redux will pass in the dispatch function for you. So inside of that function, you can fire off 4 different promises or API requests, and they can all call the dispatch with their own actions. So you can have one action that gets dispatched that results in a chain or a kind of proliferation of actions from it. This is pretty good. It's more simple than other ones. There are libraries like Redux Observable and Redux Saga. I spoke about Redux Observable just over a year ago. It's pretty nice. They're really good. Like Redux Observable is explicitly based on observables, and Redux Saga is based on the generator function and the kind of the yield style API. We didn't pick up either of these. We wrote a library instead. It's just standard engineer behavior. Like we wrote a library. We open sourced it called Refract. And this library largely came out of requirements that neither of those libraries fitted. Yeah, so a little bit about this library. We manage side effects with this library. So we call them, rather than specifically coupling ourselves to Redux, we manage this thing called side effects, and we observe stuff in the app. Side effects are anything in our React app that is not rendering to the screen. So this is dispatching anything to Redux. This is firing a download for a file when an API request finishes. Doing any kind of analytics monitoring, anything else that's not in this list. Yeah, if it's not on the screen, it's a side effect. And these were the requirements that we came with this library. We wanted to be able to observe absolutely everything in the app. This was like prop changes in your app components, Redux actions going through the store, selectors maybe changing, Redux selectors changing. Our router is actually observable as well, so we can observe route changes more easily. I think, and we also opened it to kind of extension to be able to create your own sort of observable things, which we'll see in an API in a sec. So to use this library, you import a hawk called with effects. We have versions of it for each stream library, and you pass 2 things into the hawk. You pass a function. This function takes 2 things: the props of the current hawk chain, and then a component, and that's an enhanced component. So this enhanced component lets you use things like this. So you call component.observe, and you have a stream, which is every time that prop changes, an event on that stream is emitted. So this is really easy for you to do things like debouncing of an input or autocompletes, that kind of stuff, as well as anything more complicated when you've got multiple props dependent on each other. Streams make that really easy, and Refract kind of just gives you a really simple API to deal with it. The other thing that you get is a handler. So this is basically when your stream emits, whatever it emits, it will pass it into a function, and you can do whatever you want in the function. Right? You can call any side effects, do whatever you want. There'll be things like scaling to local storage, all that stuff. It gets access to things like the store and all that kind of stuff if you want to dispatch more Redux actions. So, like I said, you can observe things on the store, whether it's a specific action that you want to know about every time it happens on a stream, or a selector when it changes. And then this is the API for the more sort of powerful version. So you get a function, and whenever you call that function, an event will appear on the stream. Cool, so, and that's kind of an example of a handler. So it's really just a function that takes an event, and you can do whatever you want inside of the handler. So yeah, in our codebase, we've kind of abstracted these a little bit more, and now in streams, you essentially, right at the end of the stream, you say what it does. So whether it dispatches whatever it has, or whether it sends it to our data layer, which is our kind of analytics abstraction. This works really well for us. It makes it really easy. The code that you actually write in business logic tends to be not more than about 5 or 10 lines, no matter how complicated it kind of is. Yeah, there's some problems we haven't figured out here. This is quite heavily based on Redux Thunk, so firing actions, firing off our thunks are passing a thunk in, or mapping into a thunk in a stream, and then firing that through dispatch. What this means is we don't get to cancel any API requests. Thunks are just sort of fire and forget. Ideally, some of the libraries like Redux Observable, you kind of create a stream which is sort of begins when the API request starts, and then it stops when the API request finishes, and you can cancel the stream midway. So this lets you do that kind of thing. And also in our codebase, we actually started with Xstream. So our XJS used to be huge, and whenever you import one single operator, you get the entire library. We used Xstream because of that, and now our XJS doesn't do that, and we're slowly moving back to it. That's not exactly easy either. So yeah, general stuff about documentation in the codebase. We use two things. We write Markdown files and we put them in the codebase. This is super easy for developers, right? Editors have integration for Markdown. There's no third-party sites that we depend on or anything like that. Literal just Markdown in the codebase. And then we use a thing called Storybook, which most of you will have probably heard if you've written React apps for a while. Heard of, sorry. This lets you write things called stories, unsurprisingly, and they are ways for you to document specific components, so render them in a web UI on their own, isolated outside of your app, and configure them like that. So, like I said, GitHub for simplicity. Storybook search is incredible. We have a really, really big Storybook at this point. We didn't really have any rules about what you could put in it. You could just put stuff in you're proud of. You could put stuff in that a designer wanted to review. You could put stuff in that needed to be documented, whatever you wanted. Storybook is huge at this point, or Storybook, so the search is great. There's some really, really good APIs and add-ons. Like we have a couple of problems where some props take there's components take like a lot of different props, like 20 plus. We would have stories which were like, for example, a button, and we would have like 50 plus buttons all rendered in one story that were just like red a bit wider, red like vertical sizing, or like different like font sizes, all that kind of stuff. So moving towards the toggle add-ons, where you can basically have a little UI in the side of Storybook where you can turn things on and off and swap the color and stuff like that, sort of eliminated that problem. And you just have one button that you get to configure in the UI yourself. Really, the purpose of Storybook is as you go through the code base and you read code and you start to understand or try and understand it, what we want to do with Storybook is go from what does this look like when you're reading that to within 10 seconds. You want to be able to answer that question, right? We started out where Storybook would take 1.5 minutes, 2 minutes to start, and basically nobody was using it because by the time you'd started Storybook, you'd forgotten what you were looking for, and you'd actually just found it in the app wherever you were going. So yeah, we host and we build a static version of it and put it in an S3 bucket and serve it internally on master merge, and that's it. And it's super simple, and that kind of eliminates that problem. This also lets people who want to use Storybook and review stuff like designers and things like that, they can all go and use Storybook, and they don't need to pull a wrap down, install dependencies, all that kind of stuff. It's great. Generally, this is like a sort of retrospective look, we would say if you're writing a story, figure out who it is you're writing it for. Is it future you? Is it the teammate who's new, like starting next week? Is it the designer? Is it like, figure that out, because if it's you, make sure it's to help you in future, and it's not just you're really proud of this thing, and you're going to be like, show someone the 60 different ways to use this component and all the things it can do, right? You basically just writing an app inside of a story, right? It just gets ridiculous. So make sure that you ask that question kind of regularly. This is the add-on with those prop, toggleable prop things. This is a good one. So as our sort of workflow is stories come out of to-do, you start work on them, or tasks come out of to-do, you start work on them. When you're finished, they go into PR review. Once they finish PR review, they go into test. When they're sitting in test, you're kind of done with them. If there's no bugs, then you're kind of done with them, but you don't really want to be picking up more and more work and just having this build-up of work in progress if test is maybe slower. So we quite often write the stories second to once something goes into test, you can start writing stories for it to keep that kind of work in progress low, and stories don't really need to be QA'd and tested and things like that, just reviewed. This is happening. Yeah, MDX Markdown that lets you import React JSX and render that in there. Super great. We're probably going to get rid of our GitHub documentation once this happens, because we can just paste the GitHub stuff in there and import the Markdown files straight into a story. That is in the alpha version of Storybook at the moment. And yeah, I've kind of spoken about that already. Don't try and say this is how we use Storybook unless you are very, very right. Don't tell people what they should be doing with Storybook. Let them decide. Next one, TypeScript. Yeah, this is an easy one for me. TypeScript over prop types every time, no doubt. Right, arguments like this. I don't want lots and lots of noise in my console. We already have lots of noise in your browser console. This is where prop type errors appear. Whereas my editor is already really good. My editor doesn't know when I violated a prop type, whereas TypeScript does, and therefore my editor does. Yeah, you fail builds when people violate TypeScript. You don't fail builds when they violate prop types. So don't use prop types. They also scale the size of the stack trace on a 13-inch MacBook Pro. The size of the stack trace is based on the number of components that you've had to render the one that has violated the prop type error. We have components that render stack traces that are higher than the height of my monitor on 13-inch MacBook Pro. This doesn't make any sense. I can't read the error when I open the console. So it also gives you this, like a lot of people, we have a lot of unit tests that cover things for components with prop types, and because they don't actually offer a guarantee, people will write unit tests to say what happens if I pass a number in here and make sure it renders the right thing instead of a string. With TypeScript, you get away with that. This is the one caveat. If you're pulling in any other library and you're using TypeScript, you need to make sure that that library has types and that they are accurate. If they are not, go and update them, go and fix them, figure out maybe another solution. But this adds an additional layer of complexity on almost everything that you use. Any other external package you use, make sure that it works with TypeScript. Styling, we use a library called Fella. We probably would have used something else by now, but they're all really just the same. There's not really that much difference anymore. You write your styles as an object or a function that returns an object. That function takes the props if you use that option, so you can write sort of props-based styles. You can say when something is hidden or in a specific state, you can change the styling quite easily. This has loads of plugins that lets us do things like media queries really easily. So in that object, you can sort of say something like at mobile portrait and put another object inside of it, and those styles will only get applied at a specific media query definition that you put in at the plugin sort of instantiation. There's also plugins for all this stuff as well. This is kind of, I don't want to spend too long on this because most people who use any form of CSS and JS nowadays get most of this for free. I would just say use CSS and JS. Find the one that works for you, but there's nothing really specific we've got from that that is really useful here. So now kind of practices. This is a big one for me. We have a lot of opinions in the front-end team, unsurprisingly. Front-end developers tend to be quite opinionated, tend to change their mind a lot of the time. Super important that when you write a PR, the purpose of the PR is the feature that you're delivering for the product. It is not for what the developer next to you or is reviewing your PR's opinion is, or it's not for you to conform to their approach or anything like that. The minute anything is in master, right, anybody can decide that something is complicated or something is not written the way they want, and anybody can go and change it, and it's completely shared. But if it's in a PR, the purpose is not to make it fit to a specific person's approach. Your automated tests and tooling should really protect you against this. So this will allow you should be allowed as a developer to go and make these changes and not need to run full regressions over the entire code base to make sure this hasn't broken anything. Any time spent manually testing regressions is really something you need to get rid of. We still have problems at the moment, but we're getting there over time. And yeah, like I said, empower your team. Make sure everybody feels comfortable to open up a file that has someone else's name all over it, and just change it to something that works for them. If they're working in it and it's not working for them, let them change it. This is the code can change. Really, the behavior of the application is what you're working towards, not the implementation. Your code base is not a canvas that you work on as an artist, right? Your code base is specifically designed to deliver features. So, some tips for this kind of stuff: keep your PR small, make them easy to review. Yeah, PRs over. We've had a few PRs that are being 2,000-3,000 lines plus, and they take up an entire day of review, usually in person, and it's really, really time consuming. It's a really big risk merging that PR. We need to do a lot of testing. Keep them small as possible, or as small as possible, and to do that, use feature flags. Get something in place so that you can turn something off in production and get stuff into master as fast as possible. Any code that is not in master is hidden from the team, right? Yeah, people talk about CI as a tool that you use, like Travis or Circle or Jenkins or something like that. Really, CI is the concept of continuous integration, where code does not live outside of master for long hours at most. Like ideally, in a true CI world, your code is a risk when it is not in master. Nobody else can see it. You know what's going on it. Get it merged as fast as possible. Obviously, if it's not broken. Adding new libraries. So yeah, when you're on a big code base, when your package JSON is doing 100 to 200 plus dependencies, it can seem sometimes for some people really easy to add another one, like what's one more than 200. For other people, they can be like there must be something else in the code base that we've already got that does this. So some kind of questions that you should probably be asking as you add a dependency, particularly in front end, right? Libraries bring in all kinds of different approaches from different languages, different frameworks. If you bring in a new dependency, make sure that if it does introduce a new paradigm or approach, right, someone has to go, and when they see this dependency, they have to then go to the docs to understand the code for it. That is a new paradigm, right, roughly speaking. Make sure that if you're doing that, it's worth it, right? Like probably put it through some kind of more stringent review process, get some more opinions, don't just add this stuff as it comes. Yep, that's kind of, I said that already. So this is a huge one. Like this happens quite a bit. It varies based on what's going on Twitter, really. Like we see it happen more and more or less, generally. I would say, if you see something on Twitter, give it a few weeks, see what happens. 9 times out of 10, it's going to disappear. Nobody will talk about it again. That's my advice. This is a huge one as well. We've started using RFCs, particularly in the team I work in. This is a really easy way to make it clear that a PR is really specifically asking for feedback about an approach. It is not a, I want to do this and I've decided we're doing this, and you just get hostility back. You get, this is not how I would do it kind of thing. This is a really good way to gather feedback on something and actually get people's much more honest opinions about something. This is actually stolen from another team in FanDuel. This statement here. We are trying to get on board with this. This is just generally, you do not need everybody's commitment within the team. Everyone does not have to say yes to a single PR to merge it. If it's something like an RFC, 70% is like roughly fine. If you can get everyone to 70% to agree to that, then everybody should be feel comfortable committing to having that in the code base. This works really well, I think. Testing. So yeah, we don't have a huge amount of test coverage, particularly like around unit tests and stuff like that. We use Jest. Jest is really phenomenal. If you're not using it, like move fast. It will enable so much more. I'm not going to talk about Jest that too much, just use it. Yeah, Enzyme, we have a lot of tooling wrapped around Enzyme to be able to test things. We have a lot of dependencies and things going on. A lot of our tests are specifically coupled to Enzyme. You want to really make them easy to write, and Enzyme doesn't really do that well. You want to have things like try and figure out metrics like this around, if I want to test this thing and I want to click this button, something goes through Redux and then something else happens. Don't stub Redux, that's kind of pointless. But know that if you need to pull in 40 lines of code to be able to set up Redux and set up everything else to then just click a button and check something else, so that you've got like a 4-line test, you've got like fix that. That's a lot of work. Your developer is spending 20 minutes to write a test that actually took them 30 seconds. This is really useful. And this one as well. We've got some tests that are either testing things that are so implementation specific and are really just flaky. The thing will break, and if the thing breaks, a load of other things will break, right? Those kinds of tests, like, just feel free to delete them. They're not really giving the value. This is a really nice quote from one of the engineers at Facebook about the purpose of tests is not actually to catch bugs, right? Like sometimes they do, and when they do, it feels really good. But really, the tests are there to pass so that your engineers have confidence that the software that they're writing is going to work. And that is a large, really large focus of your tests. I'll briefly talk about this. And end-to-end in tests. We are moving from Python and Selenium, this is sort of legacy, but into Cypress, which is really, really new and a lot of fun to write. They're a lot of fun to debug. They're really quick to run. And they have a really, really good community. They are doing features, like new features every month almost, which is great. Selenium is definitely not doing that. Yeah, keep these fast and stable, and really, like, if you want to pull out some kind of rough metrics on this stuff, if you see a test fail, how long does it take you to figure out why it failed? If it's really long, if it's too long, like it should be minutes at most, try and figure out a different way to test that, right? Figure out what it is that's failing in that test, write a test for that specific thing, or just break the test down into smaller chunks. This is a huge one. So sometimes when you're adding new dependencies, you'll accidentally add one that is not a browser dependency. It's actually a node dependency, and one of your chunks in Webpack will like skyrocket in size, and you won't really know about it. You'll just start noticing that page is kind of slow. So what we do is, once you have merged to master, we run a separate job that builds the app with a specific flag in Webpack that tells us all the sizes of the chunks, and then we send them off to Datadog on a graph. And basically, we just keep an eye on this graph. If we wanted to, if it was a major problem that happened often enough, we could set alerts up and things like that and block the release. But really, this is just about catching occasional chunks. We have 50, 60 chunks that we chip. So this is just about catching those when they happen. Hooks. Yeah, so these are really good. I'm not going to talk about these because there's just too much. We are starting to use them. They're pretty great. I'm going to skip over that. So, as headings in the wrong place in the talk. Oh. Yeah. Big things are, as an engineer, particularly in front-end code bases, if you're solving a problem and you are adding complexity, make absolutely sure that the complexity that you're adding is actually enabling other people to ship faster or ship more confidently. There is not really that much value. Like I said, this is not a canvas that you get to paint things on and decide kind of what people need to understand your code. Be careful with this one. Yeah, talking about duplication, we have a lot of code in our code base that is really, really heavily like dried up to the point of understanding any of the bits in the middle, and their use cases is really, really difficult. But yeah, be absolutely sure that when you remove the duplication between two things, you're doing it because they should change at the same time, and when you change one of them, you would expect the other to change. And even then, if you expect the other to change and it's not dried up, would you know to go and change the other one when you change one, right? If those are questions that you can say yes to, then you don't need to dry it up, right? Like, as an engineer, changing two things in two places is not that much more than changing one in one. Yeah, you'd be surprised at actually how much time is saved by making code dry. Knowing when to do this and when you need to do it, how to do it well, is actually like probably harder than most features. I would quite confidently say this. Writing code for other people to read and abstracting it properly is really difficult. 2 more blog posts. I will share the slides at the end, so you don't have to remember these links or anything like that. These are really, really useful talks. Blog posts that were come out of talks that I would recommend reading. Going to skip over all of this, but just for the people that are interested in what we use, most of us are on VS Code. We use a router called Router 5, all of the normal other tooling, and then inside of the codebase that we actually have, we have like abstractions over each of these kind of concepts. So things like A/B testing, formatters for currency, handling of copy, all that kind of stuff. There are abstractions within the codebase that make that really quick to add to your code. Yeah, what's next for us? Yeah, so this happened a couple months ago, back in May now. We made a business decision, the value of the customers that were predominantly using IE versus the value that the business makes for them, versus the value that the engineers spent time fixing IE bugs. One of our front-end engineers went out and found all that data and took it to the business and went, it's not actually worth us doing this. And the business went, yeah, that's an easy one. So now we no longer support IE and we get to use CSS Grid, and it's pretty great. This is a kind of just general list. I won't go for this one by one, but these are sort of what we're looking at next. Yeah, that's me. Yeah, do you have any questions? I'll go first. Yeah. Yeah, so there's really like a big mixture of the quality of tests or the granularity of tests and things like that. Because we use Enzyme, a lot of the tests are testing things like type of arguments, like this function outputs the correct type of thing, which should just be TypeScript. It's surprising how much of that we have. The rest of the time we try and test sort of chains of components. Like I was mentioned before, like we use quite a lot of hawks in our code base, so we will tend to test a set of hawks as a chain. So they will all do sort of specific things. We test the integration of all of those as one. That's where most of the test coverage lies. It's not actually testing the UI, the React sort of presentation component. We tend not to test that as much because it's not really where the bugs tend to be. Yeah. No question?
There was an initialism I didn't quite catch I hadn't seen before. I think it was in your code review. RFC, perhaps?
Sorry, yes. Request for comment. So it's kind of like a PR that says, I'm not going to merge this until I've got feedback. I don't want someone to just give this a thumb and then I'll merge it. This is kind of like, I want your opinions. Please come and share them kind of thing. Whereas the converse of that is, I just want you to make sure this is okay. Yeah. Yeah.
Is it Refract, the module you built?
Yes. Yeah.
That's really interesting. I just wondered that concept of streaming component state, and what was the initial problem that was trying to solve, or was it a specific problem? And what kind of products or code bases do you think that would be most applicable for using that tool?
So yeah, generally we started to find that managing dispatching of multiple actions in Redux or writing any kind of imperative code that was sort of checking the state of things became really hard to manage. And at the time, some of the more senior engineers in the codebase were quite familiar with streams, particularly a framework called Cycle.js. So it was written by the same guy that wrote Xstream and is on the core team of RxJS. They were quite big fans of that. That takes the whole stream model to an extreme. I would say once you start, if you're comfortable with the model, like it's one of the big hurdles we have with onboarding new engineers is teaching them about streams. But once that kind of you cross that hurdle, cross that bridge, it's actually quite significantly easier to write everything in streams, we find. The whole model of React is that your component is on the page for a good length, like until you remove it. Therefore, anything that happens needs to be handled asynchronously. There is not some sort of start and end to your component. It's a start and then you have to end it, if that makes sense. Yeah. Yeah.
I read about something on Twitter.
Good.
A new paradigm.
Excellent.
Called hooks.
Yes.
So I refactored my code base from Redux and Redux Thunk to hooks. And only last night I discovered I can't do asynchronous Redux Thunk kind of stuff. Do you have any advice?
Revert it? I don't know. Yeah, we have spent a good amount of time playing around with hooks. They're particularly good. Like we have a lot of stuff in context with the size of our component trees. So use context suddenly just became amazing. I think in terms of async stuff, we're probably not going to go away from Refract. We think we've kind of solved it. Like really the only thing on the horizon for React is the cancelling of actions, or the sort of risks, I guess, or the cancelling of actions and concurrent mode. So when that comes around, there's a chance that we have to figure things out a bit and maybe change approach. I would say, like on day one, like nowadays, maybe it is worth to start with hooks and you can kind of go the whole way with hooks. I think for me, the component model, handling things like use effect, being able to run as many times as it wants and be dependent, like I have a dependency array, it's quite hard. I find like I don't quite understand it. I'm someone who learned components with lifecycle methods and they're not complicated to me anymore. I can definitely understand why they moved away from them. They were full of sort of like gotchas and things like that. But I would say it's going to take us a while to get fully used to hooks. Yeah, I would stick with it.
So just kind of leading on from that, I know you mentioned with the number of Redux kind of reducers and things that you have to start filters and things onto it. Hypothetically, given the fact that things have sort of changed, would you, if you were to say start writing your code base again, still stick with Redux or use something like say Apollo and GraphQL and then hooks?
So yeah, the question was, would you stick with Redux nowadays, like on day one, would you or would you not? You would use Apollo if you could. If your API was GraphQL, or if you got to write the API in GraphQL, you probably would. Like I said, it solves so many problems that Redux just has to deal with and can't get away from. I think generally you would probably only use Redux for global state. And even then, global state is state that tends to not change that often. And so you're not really, like things like Redux DevTools are not really giving you a ton of value in that kind of stuff. You don't really care about the order of changes in global state. So I would say in the case of that, like you could get away with use context and use reducer and just like zap it straight in or wire it into your components, whatever. Yeah.
About Apollo, my first question is, do you use Apollo with React Native, and how easy is it?
Yeah, so do we use Apollo with React Native? No is the short answer. We are looking at using Apollo. We have our own set of abstractions over GraphQL because you get told about the schema up front. We can map things that are in the GraphQL API into things in the Redux store. So when we have a GraphQL request come in, we can take specific parts of it and put them in the store and make them accessible for selectors and stuff like that. We are looking at using Apollo. Like it has like really good things for support, like caching, and like there's a ton you get with it. And things that Redux really isn't that good at. But no, as far as I'm aware, we're not using it on React Native or necessarily plan to use it there yet. Yeah.
And Storybooks, same thing. Can you use it with React Native, and how easy is it?
Yes, so we have a separate code base along with this one that is 100% TypeScript and is across all 3 platforms for all UI. It's kind of like the new, fresh project, I guess. That project, I believe in the Storybook they have toggles to say that they'll give me the iOS version, the Android version, and like they're next to each other or they're toggleable. Other than that, like I think Storybook has pretty good support for that stuff. I'm not entirely sure. Yeah, I don't really spend a lot of time in the React Native stuff. Yeah.
This was very React specific.
Okay. Yeah. Cool. I think that's us. Yeah. Good. Thanks.